Today's video, it's all about having another go at casting this ventilation grill in cast iron. That was the last effort. You probably remember earlier on this year, and there's a few places there where it didn't quite fill up. So this time round I'm going to use phosphorus with the cast iron, and it makes it very fluid. This is what I'm going to add to my cast iron. It's called phosphorus. It's an alloy between phosphorus and iron, and it contains roughly 20 to 25% phosphorus. And this is what a piece looks like. Looks a bit like coke, but it's a lot heavier. So why am I adding phosphorus to cast iron to lower the melting point? Well, we need to look at this iron carbon phase diagram. Now what it shows, pure iron melts at 1540 degrees C, and this is the carbon content. And as you add more carbon, the melting point drops until it reaches here at 4.3. And at there, you can't go any further. You add more carbon, the temperature rises. But also this alloy is not a standard cast iron, it's just a straight carbon iron alloy. And if you try to cast it, it'll go hard. So what you do, you've got to add silicon. And then when you add silicon, you can change the melting point there again by lowering the carbon content, not by raising it. So if you have 3.5% carbon and you add 2.5% silicon, you'll reach that point there, even though there it says it's 4.3. But also, there's a limitation to how much silicon you can add. So what you've got to do, you've got to add phosphorus. And that temperature, the lowest melting point is 1148 degrees C. So if you go below that, you've got to add phosphorus. And how much I added was 1.5%. It's probably below the melting point of copper itself, which is about 1085 degrees C. This is the scrap I'll be using for today's melt. It's about 90 years old. It's a Buick 4 flywheel. It's lovely and chunky. This is the sort of scrap that I like to use for my melts. This is going to be an experimental melt, so I'll be using my smaller A6 crucible for the phosphorus cast iron. And now we'll see exactly how the mould turned out. Did the high phosphorus cast iron fill up the mould completely? Well, I've got my doubts because I had too much metal left over, but we'll see. Well, looks like it filled up the mould. How wrong can a man be? Here is the second mould I poured. We'll knock it out and we'll see what it looks like. Yep, looks okay. This is the last casting I poured, the third mould with the high phosphorus iron. We'll have a look at it. Yep. Whoops. Yep, turned out okay. Right, here is the casting. It's been all cleaned up and I'm really impressed. Have a look at that. All little spots. The phosphorus has lowered the melting point, so it gives it enough time to fill up all these little spots where it misrun the last time. But there is a disadvantage of using phosphorus. You've got to use a very fine sand. It does penetrate in here and it gives a rougher finish. And what happened last time, I tended to pack the sand too hard to give a smoother finish, and it broke away. But this time I packed the sand a lot softer, and you can see along here, and it broke away along there. So I'll have to use a different sand or a stronger sand. But like to show you, have a look. There is no vents anywhere in the casting, absolutely none. So you don't need air vents to fill up a mould. Now to finish off the video, I just thought I'd show you some of the pieces I didn't melt down. It came from that Buick flywheel. It shows lots and lots of blowholes in there. Even professional foundries have their bad days and they have problems with their castings. Well, what makes this a bit of a problem is anyone who restores a vintage car, and this is in the flywheel, which is a highly stressed item, it has weakened the casting. So if you spin it too fast, it's liable to fly apart.